Hi, so in this example, we're going to discuss a probability distribution such that we have some altimeters that are calibrated and not calibrated. And so in this example, we have like a supplier called Sky Ranch, and it's a supplier of aircraft parts. Included in stock are 5 altimeters that are correctly calibrated and 2 that are not. 3 altimeters are randomly selected without replacement. Let the random variable x represent the number that are not calibrated. So the random variable is the number that represents not calibrated. So when we want to do a probability distribution where x is equal to 0, 1, 2, 3, we are actually trying to find the probability in which we select 0 that are not correctly calibrated, then 1 that we select out of the 3 that are not correctly calibrated, and so on. So I think the first thing we need to do is write down what we really want to find. So the first thing is we want to note is that the random variable x is not calibrated. Another thing we want to note that 5 are correctly calibrated and 2 are not calibrated. And so that means that we have a total of 7 total altimeters. And so notice that in this case we're going to have to use some sort of combinations because it's going to be without replacement as stated here. And in this case it doesn't matter which order we select. So we're always selecting 3 altimeters. So if we have, here's 1 altimeter, 2 altimeters, 3 altimeters, it doesn't matter which one is defective. Let's say if we're doing the one that is only 1 defective in here, that means I could choose this one first, right? Then these 2, or I could select this one first, then these 2, or I could select this one and then these 2. So you can see the combinations, how it doesn't matter where I select the non-calibrated altimeter. It just matters that I'm selecting one, and it could have been the first one I picked or the second one or the third, but one of them has got to be there. So then now the second piece we want to talk about is we're going to use combinations, right? And that's because it's without replacement. And the second part is that order doesn't matter. So you can see chapter 3 is really important in these types because now we're using those probability formulas and concepts now in like a higher level of thinking. I think we have everything now. So we're going to have 3 situations, and we're actually going to have a total of 4 probability problems in one. Okay, so the first one is we let x equal 0. What does that mean? That means that if x equals 0, that means we have 0 that are not calibrated, right? Meaning none are miscalibrated. That means all 3 that I selected, right, because I'm selecting 3, are calibrated. So this means that out of 7 altimeters, I'm selecting 3, so I'm choosing 3, and none of them are miscalibrated, meaning they're all calibrated. And we know that there are 5 calibrated. Okay, so the probability that x equals 0 is actually the number of ways we can have all calibrated altimeters divided by the number of ways I could just select 3 altimeters, right? I could just select 3 altimeters and I don't know what they are, right? And then, but I want to find specifically where they're all calibrated. Out of all the altimeters that are calibrated, which are 5, I'm choosing 3 of them that are calibrated. Out of the number of ways I could just select 3. So I have 7 total, and if just the way I can select 3. Okay, so if I do that, I can go ahead and go to my calculator. And here I'm using Desmos, and if you just go ahead and go to the function on the bottom corner, it actually has trig, stats, and dist and miscellaneous. But we want the stat one, and if you look down the first column, it'll have NCR, so we're going to use that. The first one I'm going to do is I have 5 calibrated, comma, choose 3 that are, and then I'm going to divide this by and go back to the function, stats, NCR, and I have 7 altimeters total, comma, choose 3. And so here I get 0.2857, and so let me go back. Okay, so that's the first one. The next one would be x equal 1, where 1 is miscalibrated and 2 are not, right? Because we're always selecting 3. Let me write that out. We're selecting 3 no matter what. So in this case, like 1 will be miscalibrated and the other 2 aren't. So if I want to find the probability that I have exactly 1 that's not calibrated, well, that's the number of ways I could have 1 that's not calibrated and 2 are calibrated. And all over the number of ways we can just select 3 altimeters. And so this is going to be now some sort of combination like before, right? So if I have 2 that are not calibrated in my set, that means I'm choosing 1 out of the 2. And so therefore I have 2 choose 1 that is not calibrated, and means times. Out of the 5 that are calibrated, I'm going to choose 2. And then the denominator will stay the same as 7 choose 3 because I'm still just selecting 3. So if I go back to the calculator and go back to function and NCR, I would now have 2 in the stockroom that's not calibrated, but I only want 1 that isn't, times, go back to function, stats, NCR. Now I want to pick out of the 5 that are calibrated, 2 of them that are. And then I'm going to divide by NCR, 7 choose 3. So we use the comma to separate N and R. And we can see here that the probability rounded to 4 decimal places is 0.5714. Okay, so 0.5714. Okay, great. And let's go ahead and select exactly 2. What does this mean? That means 2 are not calibrated and 1 is calibrated. So if I want to find the probability that exactly 2 are, and now you can kind of see the pattern here. You're going to find the number of ways that you can have 2 that are not calibrated and one that is calibrated, all over the number of ways we can select three altimeters. So I only have 2 that are not calibrated, so it's going to be 2, choose all of them, right? 2, and 1 that is calibrated, so out of the 5, I'm going to choose 1 of them that are, and then 7, choose 3. So just go ahead and go back to the calculator and put that in. So I'll go back to function, stat, and CR, and do 2, choose 2 that are not calibrated, times function, stat, and CR, right? And then 5, choose 1, and then divided by 7, choose 3, right? Just the number of ways we can just select. So notice this probability is 0.14, and rounded to 4 decimal places, it'll be 0.1429. And so let me put that up there, 0.1429. The last one is kind of strange. I'm sure when you looked at it, you were like, why? If I wanted to select 3 that were not calibrated, but I only have 2 that are not, right? We said 2 that are not calibrated, but we want 3. Well, that would be what we call impossible. So x equals 3 means that 3 are not calibrated and 0 are calibrated. And what does that mean? Right? That means that the probability that we have 3 not calibrated is impossible because we only have 2. So this means that the probability is 0.